Okay, let's start with the atomic structure. What is the atom? Any idea about the atom? Atom is a small particle or smallest particle? You guys can open your mic, don't worry. Okay, now atom is a small particle which is base of matter. Each and everything in this universe which exists that is made up of atom. So again, I repeat, what is the atom? Atom is a small particle which is base of matter. There are three fundamental particles of atom. Those are there are three fundamental particles of atom. Number one, it's going to be proton or positron. Use the term proton. And the next thing is electron. And the third one is a neutron. Proton, electron, and neutron. These are the three fundamental particles of atom. Proton, electron, and neutron, their relative charge. And the next thing is going to be relative mass. Actually, these are not the actual charges or actual masses. Relative charge for proton is +1. Electron is -1. Neutron is neutral, or it does not has any charge. Neutral or zero charge. Again, I repeat, proton, they are +1. Electron, -1. Neutron, they are neutral. They don't have any charge. And relative mass for proton and neutron, they are 1 and 1. And mass of electron is 1/1836, or you can write approximately 0 because this is a very small number. And due to the small number, you can take mass of electron approximately 0. So this was about relative charges and relative masses. Actually, these charges, they are not the original charges. They are in relation to each other. So +1 and -1, they are in relation to each other. For example, if you see original charge of a proton, that is +1.6 multiplied by 10 raised to power 20 or 10 raised to power -19. And for electron, it's going to be -1.6, 10 raised to power -19. Now you can see they have same charges, number is the same, but proton, they are positive, electron, they are negative. So in relation to each other or ratio, they are going to be 1 and 1. So +1 and -1, these are the relative charges for proton and electron. Okay, now what will happen when you pass these three fundamental particles of atom through the external magnetic field? This is external magnetic field. On this side is a positive side. And the other one is a negative side. This is negative, it's a positive, and it's a neutron. This is electron, and here you have a proton. Neutron will go straight, it does not has any charge, so there will be no attraction. This neutron will not move on any side, not positive, neither positive nor negative. It will go straight because neutron, it's a neutral, it does not has any charge, so there will be no effect of external magnetic field on this neutron, so it will go straight. And what about electron? Electron, you have learned in your junior classes, opposite charges, they attract each other. Electron, it's a negative. Proton, this is a positive side. So this electron will be deflected towards positive side. And with a proton, opposite thing happens. Proton will move towards the negative side. Now, when you see the angle or deflection, this is a deflection for the electron. Okay, now this is for the electron. And it is for proton. Now, can you tell me which one is facing more deflection, proton or electron? Gee, guys, if you see the angle for electron, this is the angle of deflection for the electron, and proton, it is deflected after the after the electron. What is the reason why electron is facing more deflection? This electron with the one which is negative charge, it is deflected more. Yes, so Zoha, you're right. It's facing more deflection. Why is facing more deflection? Because mass of electron is approximately 0, or you can say 1 over 1836, or mass of this electron, it's going to be 0, and mass of proton, it is 1. So the one which has low mass, it will face more deflection. The one which has higher mass, it will face lesser deflection. ये ऐसा ही है जैसे there are two objects, one is heavier and the other one is lighter particle. And if you apply same force on the same angle, the one which has lighter, it will cover more distance, and the one which has more mass or heavier, that will cover less distance. So this proton will face less deflection, and electron will face more deflection. Okay, now next thing is proton number or atomic number. Both are the same thing. Proton number or atomic number, both are the same things. And the second point term you must know, that is atomic mass or nucleon number. Atomic mass, or you can use a term nucleon number. Now, atomic number or proton number is, these are the number of protons present inside the nucleus of atom. Okay, again, I repeat, what is proton number or atomic number? These are number of protons present inside the nucleus of atom. That is atomic number or proton number. Keep in mind, this number of proton or atomic number is unique for a specific element. Later on, I will discuss this thing, why they are unique. Now, if an atom that has atomic number 12, its number of protons will be 12. If an atom has 15 atomic number or proton number, so its number of protons inside the nucleus, that is going to be 15. And in a neutral atom, make sure number of protons are equal to the number of electrons. If an atom has 12 protons, electron will be 12. If an atom has 20 protons, the number of electrons will be 20. So make sure this number of proton in an atom, number of protons, they will be equal to the number of electrons. If an atom has 50 protons, electron will be 50. If an atom has 100 protons, electron will be 100. So this proton and electron, they will remain same. And atomic mass or nucleon number is, these are the total number of protons and neutrons. Total number of protons and neutron, that is known as atomic mass number or nucleon number. Why we call it nucleon number? Reason for the nucleon number is because these are the particles, proton and neutron, they are present inside the nucleus of atom. So this is the reason we call them nucleon number. Or in other words, you can say these are the total number of particles. Nucleon number tells you about total number of particles which are present inside the nucleus. So we call them nucleon number. So proton number or atomic number is its number of protons present inside the nucleus of atom. Atomic mass is, or nucleon number is, number of protons and neutrons. Now, in atomic mass, why we are not considering number of electrons? Technically, in the atomic mass, there should be number of electrons, they should be considered. But we are not considering number of electrons. We are considering only number of neutrons and protons. Now, can anyone tell me why we are not considering number of electrons in the atomic mass? Yes, Huzafa, excellent. The mass of electron is 0. So this is a reason we don't consider number of electrons in the atomic mass. So mass of electron, again, I repeat, mass of electron, it's equal to 0 or it's very small number. So we don't consider in the atomic mass or nucleon number. Now, one more thing I want to tell you about number of protons or atomic number, that is, number of protons, they are identical for a specific element. They are just like a fingerprint for an element. Fingerprint means your fingerprint is unique for you. Your fingerprint cannot match with any person in this universe. So they are identical for you. The same thing happens in the atom. Number of protons, they are unique for a specific element. If you discover an atom which has one proton, it should be hydrogen. If you change the number of protons, the type of element or atom will change. For example, this is the hydrogen, has atomic number 1, it has 1 proton. But if you add 1 more proton into this hydrogen, it will become helium because helium has 2 protons. So this number of protons, they are identical for a specific element. Two different atoms cannot have a same number of protons. So number of protons, they will be different for different substances. So if you change the number of protons, nature of element will change. For another example, carbon has 6 protons and nitrogen has 7 protons. If you add 1 more proton into the carbon will turn into nitrogen. And if you add more proton or 1 more proton into the nitrogen atom, it will become oxygen because oxygen has 8 protons inside the nucleus. Okay, now come towards this proton, electron, and neutron. Proton and neutron, they are present inside the nucleus of atom. This is proton, and here you have neutrons. They are present inside the nucleus of atom, and nucleus is at the center of the atom. And electrons, these electrons, they are present inside the shells, which are present around the nucleus. So technically, if you see the structure of atom, it contains 2 things. Number 1 is a nucleus. Inside the nucleus, there is neutron and proton. Electrons will be in the shells. So number of shells depend on the number of electrons. जितने ज़्यादा electrons होंगे, उतने number of shells होंगे. Now, by using this, can you find out number of proton, electron, and neutron inside the atom if proton number and atomic mass is given to you? For example, this is the argon. AR is a symbol for argon. It has the 40 is number, and this is 18. By using these numbers, can you identify which one is atomic number and which one is atomic mass? The one which has smaller number, that is atomic number, and the one which has bigger number, it's atomic mass or nucleon number. So it is nucleon number, or another name for nucleon number is atomic mass. And 18, it's a number of proton or proton number. Okay, now this argon contains 18 atomic number. If atomic number is 18, so its protons, they are 18. And I told you number of proton and electron, they are same. So electrons, they are 18. And for neutron, this number is telling you about the number of protons plus neutron. So total mass is 40. So 40, it's proton plus neutron, they are equal to 40. We know number of protons, they are 18. Total is 40, protons, they are 18. So by using this equation, you can find out number of neutrons. So number of neutrons, protons, they are 18, plus neutron is equal to 40, and neutrons, they are 40 minus 18. So 22, these are the number of neutrons. So this was a way how you can identify number of proton, electron, and neutron by using number and mass number. Another example, it's iron. Fe is a symbol 56 and 26. The smaller number is number of protons or atomic number, bigger number is atomic mass. So if protons are 26, atomic number is a 26, so protons are 26. Electrons, proton and electron, they are same. So it's 26. Neutrons are 56 minus 26. So your answer will be 30. So this was the way how we can identify number of proton, electron, and neutron if atomic number and mass number is given. Now, can you find out number of proton, electron, and neutron in these substances? That's number one. Number two. Now, you have 2 minutes to find out number of proton, electron, and neutron for these elements. Number 1, 2, 3, number 4, 5, and this is 6. Okay, Josefa, good. Now check your answers. For protons, chlorine atomic number is 17, protons are 17, electrons 17, neutrons are 37 minus 17, it's 20. Number of proton for bromine 35, electron 35, neutrons, they are 45. 20 proton, 20 electrons, 22 neutrons. Again, proton, electron, and neutron. Protons are 7, electrons 7, neutrons, they are also 7. It's 12, 12, and 13. It's 30, 30, and 35. Check your answers. So this was the way how we can find out number of proton, electron, and neutron if atomic number and mass number or and atomic number and atomic mass is given to you. Now, any question related to this? Let's go how we can draw the structure of the atom if all the data is given to you. And I told you proton and neutron, they are inside the nucleus of atom. A nucleus is at the center of the atom, and electrons, they are present inside the shells or energy levels. So for this, we use electronic configuration. Electronic configuration, actually, it's a system which is used to distribute the electrons in the shells. That is known as electronic configuration. So it's a system which is used to distribute the electrons inside the shells. That is known as electronic configuration. So according to this electronic configuration, first shell can accommodate maximum of 2 electrons. We don't use 2n square formula. 2n square formula will be used in your A levels. So in the O levels, first shell can accommodate maximum 2 electrons. And second shell, it can accommodate 8 electrons. The third, fourth shell, they can have maximum 8 electrons. So 2, 8, 8, and 8. There is no 18 or 32. If you have learned this formula, 2n square, this 2n square will not be used in O levels or IGCSE. This formula you will learn in A2. This is for A levels. So in your O levels, first shell can accommodate 2 electrons, second, third, fourth, they can accommodate maximum 8, 8, and 8 electrons. Now, if we go for this sodium, atomic number is 11 and mass is 23. How we can draw the structure of atom? So very first thing, we will find out number of proton, electron, and neutron. Protons are 11. Electrons, they are also 11. And neutrons are 23 minus 11. They are 12 neutrons. So this proton and neutron, these two things, they will be inside the nucleus. So this is the nucleus, which contain protons and neutron. So first, it's 11 protons and 12 neutron. And for electrons, we will do the electronic configuration. This is the electronic configuration. There are total 11 electrons, and we have to accommodate these electrons in the shells. So for this, it's 11. First shell can accommodate maximum 2 electrons. How many electrons are left? Total electrons, they were 11 in the sodium. So first shell is filled. Now we'll go for the second shell. Remaining electrons are 9. So out of 9, 8 electrons, they are accommodated in the second shell. How many electrons are left? 2 plus 8, 10 electrons. They are accommodated. 1 electron is left. That remaining 1 electron will go in the third shell. So this is 2, 8, and 1. It is the electronic configuration. If examiner asks you to do electronic configuration, you will write this 2, 8, and 1. If examiner asks you to draw the structure, for that we will draw structure like this. First shell, it can accommodate maximum of 2 electrons. This is the first shell, 2 electrons. And the second shell, it can accommodate maximum 8 electrons. Now try to draw the electrons in the pair form. Don't draw the electrons in single form. 2, and this is 8 and 8. The third one is 2, 8, and the last one, this is known as outermost shell. So it is in the valence shell. So outermost shell is known as valence shell, and electrons in the shell, valence shell, they are known as valence electron. So chemical properties depend on valence electron. Physical properties depend on the nucleus. So if you predict the physical properties, you will see its nucleus. Protons and neutrons, they will determine the physical properties. Valence electron, they will determine the chemical properties. So this is the significance of the valence electron. So outermost shell, it's a valence shell. And chemical properties depend on number of valence electron. If two atoms, they have same number of valence electron, their chemical properties will be same. And another example, how we can draw the structure. For example, it's calcium. It's 42 and 20. First of all, find out proton, electron, and neutron. Atomic number for this calcium, it's 20. Mass number is 42. So protons, they are 20. Electrons, they are 20. Neutrons are 42 minus 20, 20. And number of neutrons are 22. This is a nucleus. This nucleus contains 20 protons and 22 neutrons. This is the nucleus. And very first shell, it can accommodate maximum. How many electrons? 2. Now do the electronic configuration for 20. Its first shell can accommodate 2. How many electrons are left? So remaining electrons are 18. So second shell can accommodate maximum 8 electrons. So 10 electrons, they are adjusted here. And out of 20, 10, they are adjusted. So remaining electrons are 10. So for remaining 10 electrons, we go for the third and fourth shell. Third shell, again, can accommodate 8. So 2 plus 8 plus 8. 2 plus 8, it's 10. Plus 8, 18. And the remaining 2 electrons will be in the outermost shell. So first shell, it can accommodate 2 electrons. And the second shell, again, it can have maximum 8 electrons. It's 2, 8, and 8. Third one is, again, it can accommodate maximum of 8 electron, 2, 8, and again it is 8. And the last shell, this last shell is known as valence shell, and valence shell contain 2 electrons. So these electrons, we say they are valence electron. Valence electron will determine the chemical properties of an element, and this shell is known as valence shell. So this was the way how we can draw the structure of the atom. Now I'm going to give you different elements. You have to draw the structure of these elements. Silicon, 14 and 28. Number 2, it's aluminum, it's 13, 27. Number 3 is argon, 18 and 40. Number 4 is magnesium, and 24 and 12. Number 5 is nitrogen, 7 and 14. Number 6 is it's potassium, 39 and 19. 19 is the number of proton and 13 is mass. And number 7 is phosphorus, 31 and 15. Draw the structure of these elements. I'm giving you 45 minutes for this. You guys done with the structure of these atoms? Okay, Vadia 284, right. Aluminum, it's 283, argon 288, magnesium 282, fine, good. I'm going to draw the structure for these substances. Sorry, guys. This is silicon. It contains 14 protons and 14 neutrons. And its electronic configuration is 2, 8, and 4. This is a structure for silicon. And for aluminum, both are same, but there is only one thing different. This aluminum has one less proton and one less electron inside the nucleus. So again, I'm going to use copy and paste. तो गुस्सा ना करना प्लीज, क्योंकि ये टेक्नोलॉजी है. अक्सर मेरे स्टूडेंट कहते हैं कि सर ये आप ज्यादती करते हैं हमारे साथ, कि हमसे तो ड्रॉ करवाते हैं और आप खुद कॉपी पेस्ट कर लेते हैं. So it's 13 protons and 14 neutrons. And for argon, argon contains 18 electrons and 18 protons, and neutrons, they are 22. Its electronic configuration is 2, 8, and 8. This is a structure for argon. And for magnesium, they are again same. But instead of 14 protons, it has 12 protons and 12 neutrons. And outermost shell contain 2 electrons. So this is 2, 8, and 2. And for nitrogen contains 7 protons and 7 neutrons inside the nucleus. And its electronic configuration is 2, 8, and 7. So it's going to be 2, 8, 2 and 5. Yes, this is 2 and 5. For potassium is going to be 19 protons and 20 neutrons. Its electronic configuration is 288 and 119 protons and 20 neutrons. It's 2, 8, and this is also 8. And the valence shell, it has 1 electron. And for phosphorus is 31 and 15. Its electronic configuration is 2, 8, and 5. So this was the way how we can draw the structure of the atom. Okay, that's for today's class. So in today's class, we have learned what is the atom. Atom is a small particle which is base of matter. There are 3 fundamental particles of atom. Those are proton, electron, and neutron. Protons are positive charge, electron negative, neutron, they are neutral. Relative mass 1 and 1 for proton and neutron, and for electron it's going to be 0 because this is a very small number. This is the effect of external magnetic field on the movement of proton, electron, and neutron. Neutron will go straight because it does not have any charge. Proton will be deflected towards negative side, electron deflected towards positive side because they have opposite charges. Electron is deflected more. Why? Because it has smaller mass. So due to the smaller mass or lighter particle, it is facing more deflection. Proton is heavier particle. So this is the reason it was facing lesser deflection. So after that, we did proton number, atomic number. You can revise all the stuff. So that's all for today's class. Any question related to today's class?